Hi and welcome to Electrical Engineering Planet. And in today's video we will learn what is explosion proof factor, which is very important in some applications like oil and gas applications and mining applications. So please consider subscribing in Electrical Engineering Planet channel to support our community. Also don't forget to share, like and let knowledge enlighten your world. So, any area that contains hazard must have an electrical explosion proof factor. So, for example, if you have a motor that is inside gas area, this gas are flammable gas. So, this is a hazard actually. So, you will find in this motor on the nameplate an explosion proof factor. So, in this video, you will find exactly what is explosion proof, how we can read it, what is the symbols behind it, so you can understand it and you can design. Also, you will understand what is the zones of dangers, could be zone 0, zone 1, zone 2. And also, you will find out how to design an electrical equipment that suits this hazards area with the right explosion proof factor. First of all, we have to know what is ATEX. ATEX actually stands for Atmospheres Explosibles in French. I hope I could pronounce it right, which means explosive atmospheres. So, this is a European directive system that ensures electrical and non-electrical equipment that is used in hazardous areas like oil and gas areas, like mining, like factories or places with flammable gases or dust, is safe and doesn't cause explosions. So, if you have a motor, as I said before, inside a flammable gas area, so this is a very hazard place. So, if this motor have a spark inside or could have an explosion in the windings, for example, if this explosion or if this spark reaches to the flammable gases outside, this will cause a huge fire, a huge explosion outside. So, explosion proof factor means that if this motor has an explosion or fault inside, it will never reaches to the flammable gas outside. So, it contains the problem or the fault inside without having or without going outside to the flammable gas. Here actually ATEX or the European directive system have two codes or two different standards. The first standard is for manufacturers and the second one is for users. So if you want to design an electrical equipment that have an explosion proof with a specific level, you will go to the first standard. But if you are a user, like a one who has a factory or one who has a mining place and you want to buy a motor, you will use the second code. Now, what is ATEX certification marking? As you see in the right, you will find inside the nameplate of your electrical equipment this code, and this code actually have a lot of symbols. Every single symbol of those will give you a specific or describe a specific safety level, environment level, protection methods, and temperature class, and so on. So here you will find out which zone this motor could work in and which protection method is used here. Is it deal with gases or dust? What is the maximum temperature surface that this motor is designed to be in? Also, what is the equipment protection level? So, in the left here in the example, IECEx 2 in the Latin way, 2G EXDB 2 in the Latin way, CT6GB. Every single symbol of those have a different meaning. So for example, CE here means this is according to ATEX or the European directive systems. EX means that it's explosion-proof equipment. Very good. 2 in Latin means the equipment group, and we will find out exactly in the next slides what is equipment group. After that we have 2G. G means gas. If it's D means dust. And 2 means equipment category, and we will find out exactly what is equipment category. Also EXD or EXB, it's a type of protection. What is the protection methods we are using here to protect this electrical equipment? 2C in Latin, this is something called gas group. Is this gas is very dangerous, medium dangerous, or not very dangerous? T6 means the temperature class or maximum surface temperature level. GB means equipment protection level. And we will find out every single one of those, what is the meaning of it, in the next slides. Let's move forward and find out the first thing, which is equipment group. Here you will find a Latin letter, 1 or 2. 1 means you are working in application of mining, so you are dealing with methane or coal dust. Those are the dangers that is inside the mining. But in group 2, you are using it inside an application of surface industries, like oil and gas companies, chemical companies, and so on. So here, in the first example here, 2 in Latin, this letter means that we are inside the surface industries, like oil and gas company, for example. So we are not in mining application. We have G or D, as we said before. G means gas, D means dust. So this factor describes type of explosive atmosphere the equipment is designed for. So G or gas is explosive gases, vapor or mist. D is explosive dust in the air or on surface. So as you see here, G is gas. What is 2 behind G? It's an equipment category. An equipment category actually describes level of protection where the equipment can be safely used in. So, for example, if we are in group number 1 in mining applications, you will find out that there is no letter 2 here. You will find it in M1 or M2. M1 means the protection level is very high, and M2 means that the protection level is high. What does that mean? It means that your equipment remains working during explosive atmosphere. So, if you are working in atmosphere that have a lot of gases, your motor could be working without any worries. Why? Because it's M1. So, we are giving it a lot of protection so that any problem or fault happens inside will never affect on the explosive atmosphere outside. So your motor can be working safely. M2 means the protection level is high. So it's not like the very high M1. So your equipment will be shut down during explosive atmosphere. So in case of there is no explosive atmosphere outside, the equipment will work. But once an explosive atmosphere appeared suddenly, your equipment must be shut down. This is for group number 1, but our example here actually for group number 2, which is a surface application or non-mining applications like oil and gas. So here, as you can see in oil and gas application, our group number 2, we have 3 different values: 1G or 1D, 2G or 2D, 3G or 3D. G for gas, D for dust, as you know. But 1 actually means the protection level is very high. 2 means it's high. 3 means it's normal. And as we said before, very high means that your electrical equipment can work during an explosive atmosphere outside present continuously or for long periods. So you can work while there is an explosive atmosphere outside, because our protection level is very high. So this equipment have a lot of protection. But 2G or 2D means that your explosive atmosphere will not be outside. When it's present outside, your equipment must be shut down. So, as you see here, where explosive atmosphere are likely to occur occasionally, not always. Here for normal, this where explosive atmosphere are unlikely or only occur briefly. It will never happen maybe. So they have separated the zones into 3 zones here. Zone 0, Zone 1, Zone 2. The working areas in Zone 0 means that it's very dangerous places where explosive atmosphere are present continuously. So, at Zone 0s, you have to have a motor with protection level very high, or 1G or 1D. But Zone number 1, where explosive atmospheres are likely to occur occasionally, so the protection level you must have is high. So, your equipment must have 2G or 2D. In Zone 2 is not dangerous place actually. So the protection level will be normal, and you have to buy an electrical equipment with 3G or 3D. You can ask me, what if I am in Zone 2, but I have bought a motor with 1G, very high protection? Why I should take care of normal, high, and very high? I could buy very high or 1G or 1D electrical equipment and not to see this table. Actually, this means that you will pay a lot of money unnecessarily. So if you are in Zone 2, you can buy a motor with a little amount of money. But if you decided to buy a motor with very high protection, you will pay a lot of money unnecessarily. So as you see here, we have Zone 0, Zone 1, Zone 2. This is for gases. And they call them Zone 20, 21, 22 for dust. Very good. So let's return back. Here, as you can see, 2G. 2G means that the protection level is high. Not very high and not normal. Okay? Now let's see what is EXD or EXB or whatever. This is what we call types of protection. This is actually the method that we are using to make this electrical equipment safe to use in explosive areas. So for example, we have here a table with code and methods. It could be D, E, I, P, O, M, N. D actually it's a flame proof, which means that it contains explosion inside. As you can see here, if there is an explosion inside the junction box, for example, it will be contained, and there is flame passes that will give this flame some passes to move on, and it will never go outside. For E, or increased safety, we prevent spark and temperature from the beginning. So we prevent our equipment from having the spark or temperature from the beginning. In intrinsic safety I, we limit energy. So for example, we decrease the voltage from 220 volt to 24 volt. And the 24 volt is not sufficient to make an explosion. P, or pressurization, we use protective gases. O, oil immersion, we submerge our electrical equipment inside oil to decrease the effect of spark or temperature, high temperature. M, or encapsulation, we sealed our electrical equipment in compound. N, or non-sparking, this is limited to Zone 2. Zone 2 is the normal zone. It's not dangerous zone. So let's see our types of protection much more in detail. D, or flame proof. Here the explosion is contained inside the enclosure. It won't escape and ignite the external atmosphere. And we provide some flame passes to this flame proof. Here, for increased safety, our equipment is designed to avoid sparks, high temperature, and arcs under normal use from the beginning. So we will not have sparking, and we call it not for sparking devices. I, or intrinsic safety. Here the energy is limited to levels too low. That is not sufficient to cause ignition, even with volts. So for example, if we have a 220 volt, we will decrease it to 24 volt. This is not sufficient to make a problem actually. P, or pressurization, this is a protective gas. Is kept inside under pressure to keep hazardous gases out. So it keeps the hazardous gases outside. O, or oil immersion. As we said, parts are immersed in oil to prevent contact between electrical parts and explosive gases. M, or encapsulation. Those explosive parts are fully encapsulated in resin, so the gases can't reach them. N, or non-sparking. This is used for zone 2, which is a normal zone or low risk zone, and devices are made to avoid arcs or heat but are less strict than IECE, for example, which is increased safety. Let's return back and see here. As you can see, EXD, for example, EXD is a flame proof. Very good. Let's return back and see what is the letter 2 in Latin, C. This is a gas group. Gas group actually is the classification that helps us to determine which gases or vapors is safe to operate around. So here we have 2A, 2B, 2C. 2A is least explosive. It's not dangerous, like the propane, methane, ammonia. 2B is more explosive, like ethylene, hydrogen sulfide, and so on. The 2C is most explosive. It's the most dangerous. It's hydrogen, acetylene, carbon disulfide, and so on. And let's return back and see 2C here. It's the most explosive and dangerous gases group. Very good. So we have to take care of. Now let's see what is T6, or temperature class. Here the temperature class define the maximum surface temperature of an equipment that shall not exceed. So here we have a table. T1 means the maximum surface temperature is 450 degrees Celsius. T3 is 200. T5 is 100. T6 is 85 degrees Celsius. So as T get more value, like T1 is not very dangerous actually place. But T6, you are working inside a very dangerous place. What does that mean? For example, as you can see in the picture here, this is a motor. This motor is a T4. T4 means that the temperature could reach to outside this motor to 135 degrees Celsius. It will not exceed this value, okay? But this motor is working around a very dangerous gas. This gas is called carbon disulfide. And this carbon disulfide has an auto-ignition temperature of 95 degrees Celsius. What does that mean? It means that if the ambient temperature or the surrounding temperature around this gas reaches to 95 degrees, it will make this gas to start exploded or start have a fire. So this motor have a wrong design. It's wrongly designed because we need here a temperature, a much less surface temperature. So we need a motor that will never reaches to this temperature, because a 135 degree will cause an ignition actually. So let's choose T5. T5 is 100 degree, also wrong. Why? Because if the motor reaches to the maximum value 100 degree, it will also cause an ignition for the temperature 95 degrees Celsius for the carbon disulfide. So we will choose T6 because it's a very dangerous place. So we have to choose T6, which is 85 degree. So now our motor will never exceed 85 degrees Celsius, which is less than the auto-ignition temperature of carbon disulfide. So let's return back to our example, and you will find out here it's T6. T6 means that we are in a very dangerous place because the motor will never exceed 85 degrees Celsius. And this is logic actually, because we are in 2C, the group gas is 2C, which is the most explosive and most dangerous gas group, which is hydrogen or acetylene or carbon disulfide. But what if we are working in 2A? In 2A we have propane, methane, ammonia. It could have an auto ignition temperature of 400 degree, for example. If we have 400 degree, we will choose T2, class of T2. If the temperature of auto ignition is 250 degrees Celsius, we will choose T3, less than the value. Very good. Now let's move on and see what is EPL, or protection equipment level. Here, as you can see in the example, we have GB, and this is the protection level or equipment protection level, EPL. This actually defines the level of protection provided by equipment intended for use in explosive atmospheres. So it tells us how the equipment is to cause an ignition and how safe it is to use in different zones. Here, for example, we have a table GA, GB, GC, which means gas, gas A, gas B, gas C. A means we are working in zone 0, B means we are working in zone 1, C means we are working in zone 2. But here DA, DB, DC. DA is dust A, dust B, dust C, means zone 20, 21, 22. And as you know, 20 is very high, 21 is high, 22 is normal. Also, zone 0 is the very high or the most dangerous place. So it's safe if we have a classification for the electrical equipment of GA. It's safe even when explosive gas is outside this electrical equipment. So this electrical equipment can work fine even there is an explosive gas outside. But GB means that the normal operation, it could be normal operated, but without this gas outside. But it could happen and we have this gas outside, and at this moment we have to shut down our equipment. But for GC means that it's very rare to have a presence of explosive gas. And as you see here, this protection equipment level factor, it's much more like equipment category. Here, as you can see, for example, group 2, we have 1, 2, 3, 1 very high, 2 high, 3 normal, and the explosive atmosphere are present continuously. And as you can see, this equipment category is enough. Why we are using this protection equipment level also? Because actually this EPL factor is a universal language. You can use it with ATEX or other different standards. So other different standards can understand this factor of protection equipment level. So anyone who is using another factor or another standard rather than the ATEX, if he read the protection equipment level, for example GA, he will understand everything. So we are using it here because it's a universal language that everyone can understand. Let's make a revision now. CE means the ATEX or the European directives or standard. EX means explosion proof equipment. 2 means it's non-mining or oil and gas. 2G means gas, not dust. 2 means that we are working in an area of zone 1, which is dangerous, but not very dangerous like zone 0, and not very normal like zone 2. So 2 here means zone number 1. 1 means zone 0, which is very dangerous, and 3 means zone 2, which is not dangerous at all. EXD is the type of protection which is flame proof. 2C means the gas group. This is a very dangerous gas group. T6 is the temperature class or the maximum surface temperature of an electrical equipment. GB is EPL or equipment protection level, which is the universal language that every standard can understand, and it's much more like equipment category. Hopefully you are fully understand this topic because it's a very important topic, and consider subscribing in Electrical Engineering Planet channel to support our community. Also, don't forget to share, like, and let knowledge enlighten your world. Thanks for watching.